Hello. This is going to be the PreCalc section 9-1 called Arithmetic Sequences. This is out of Edgenuity. This comes with 4 different objectives. Find the common difference of an arithmetic sequence. Determine if a sequence is arithmetic. Apply the formula of an arithmetic sequence. And find the terms of an arithmetic sequence. So let's get looking at our first problem here. And our first problem asks, which table represents an arithmetic sequence? So the first thing we have to know is what is an arithmetic sequence. And an arithmetic sequence is any sequence that has what they call a common difference. All that means is that you're adding the same number over and over again. So what we want to do is we want to look at these bottom pieces here on each of these tables, and we want to see, do I keep adding the same thing each time? So like for this one, for example, to go from -6 to -12 is adding -6, right? And then to go from -12 to -4 is adding -12. So it's not going to be that one. Okay? So we're eliminating that as a possibility. So not that one. Let's look at choice B. And we're going from 7 to 9, that's adding 2, that's doing +2. And then we're going from 9 to 13, that's doing +4. So again, we're not adding the same thing each time, so we are going to not have this be a part of it. This is not our answer. And then finally, let's look at this one. We go from 8.7 to 7.3. And if you look there, you're adding a negative what? If I subtract these two, it's going to be 1.4, right? And then from 7.3 to 5.9, and if I look at these two, what do I add to go from 7.3 to 5.9 is again -1.4, because if you do 7.3 minus 5.9, you get 1.4. If I go 5.9 to 4.5, subtract those two, again, I'm adding -1.4, and to go to 3.1, I am again adding -1.4. So I am subtracting 1.4 each time. You can think of it that way as well. Okay? So that is that, and then the next question is, what is the common difference for the arithmetic sequence? And that would be -1.4. That is to say, every time that I add, the thing that I add is what we call the common difference. And so every time that I add -1.4, I get the next number in the sequence. Okay? I'll let you look at that for a second. Let's go on to the next question. All right, so this one says, write a rule to find the next term, the nth term, the a sub n, for this sequence, which is arithmetic. And then it asks, what's the next term? So the idea is, for the next term, for the nth term, we're going to take the previous term, that's the n minus 1th term, that is the term right before the next term, and we're going to add whatever the common difference is. And so we need to look at two of them and say, what am I adding next? So to go from 39 to 60, or to go from 60 to 81, for me, I would look at from 60 to 81 because I know they're all going to be the same. And for me, that's the easiest one to say, okay, what am I adding to go from 60 to 81? Well, I'm adding 21. So there's my rule, so-called rule, for finding the next term. And so if I look at that and I go, if, say, you count how many we've got here, 1, 2, 3, 4, 5. If I'm looking for the 6th term, I would take the 5th term, so the 6th term, and then the 6 minus 1th term, the 5th term, and I would add 21, which makes the 6th term 123 plus 21, which is, if you do the math real quick on that, you get 144. So that 6th term, the next term, is 144. I'll give you a moment to look at that. All right, and then let's move on to our next problem. All right, this one says the explicit rule. So the explicit rule is the rule where you can just plug in whichever one you want. So I don't have to know the previous term to get the next one in the sequence. And this is really neat about these explicit rules. I can just say, here's the explicit rule. I want the 11th term. I want A sub 11, the 11th term of the arithmetic sequence. And I can just plug in and get it, right? So they give me an explicit rule or an explicit equation that says to get the nth term, that is some specific term in the sequence, take that number of term that you want and plug it in right there for n, and do the arithmetic and figure everything out, okay? The first question is, what is the common difference? So the reason they ask that as the first question is because that's kind of how they present it, that is Edgenuity. That's how they present these formulas is, hey, this part of the formula tells you the common difference, and this part of the formula tells you this. But I actually want to focus on this question first. What is the first term? Because that is the question that can help lead us into everything else, okay? So let's look at the first term, a sub 1. That would be negative 4 plus 1, that's n is 1, right? That's the n that I'm concerned with, minus 1 times 7. So what does that give me? Well, that gives me negative 4 plus 1 minus 1, which is 0, times 7, which gives me negative 4 plus 0, which is just negative 4. So the first term is negative 4. Let's focus on part of this next question. Write the first 4 terms. Well, let's at least get the second one, okay? That would be negative 4 plus 2 minus 1 times 7, which is negative 4 plus 1, 2 minus 1 is 1, times 7, which is negative 4 plus 7, 1 times 7 is 7, which is 3. Okay? So, so in my sequence of numbers, let me do that over here. I go from negative 4 to 3, and then I've got some more. But how did I get from negative 4 to 3? Well, I added 7, right? And since this is an arithmetic sequence, that's what I'm going to do each and every time. I'm just going to keep adding 7. So I can come up with the other ones. I can get the rest of this answer just by adding 7 over and over again. 3 plus 7 is 10. 10 plus 7 is 17. So now I've answered what's the first term, what are the first 4 terms, and by exploring that, I've been able to answer that one right there. What is the common difference? The common difference is plus 7. I'll give you a chance to look at that for a moment. And I should add, so that was right there. That was the common difference, was 7 or plus 7. And it goes right next to this part. It's the multiplication, which should make sense because the really basic definition of multiplication is to add the same thing over and over again. So if I keep adding 7 to get the next term and the next term and the next term in the sequence, then overall you can think of that in a way as multiplying by 7 over a long period of time, right? You can also see that the first one gives me a 0 right there, which leaves me with just a negative 4. So in these explicit rules, there's the first term, there's the common difference, and there's sort of the formula bit that gets you there. Okay? I'll give you another moment to look at that. And let's go on to the next one. All right, so now I want to write the explicit rule, which is what we're looking at back here. This was the explicit rule right there. We want to write an explicit rule. Whoops, going the wrong way. We want to write an explicit rule for an arithmetic sequence with the first term being 42 and a rule that says add 8 to get the next one and the next one and the next one. So let's explore that. Let's write down a few of these, and then we'll try and write the explicit rule, and then we'll double check whether that's helping, things of that nature. Okay, so 42, if I add 8, that gives me 50. 50, if I add 8, that gives me 58. 58, if I add 8, that gives me, what is that, 66. And 66, if I add 8, that'll give me 74. And that's enough. That's the first 5 terms, so I can check my explicit rule pretty well. I can check like the second one, the fifth one, that sort of thing. So let's look back again at how they wrote this explicit rule. They start with a sub n, the nth term, equals. And then they give the first term, and then n plus n minus 1 times the common difference. So the first term, 42, plus n minus 1 times the common difference, and the common difference is that we're adding 8 over and over again, right? So that becomes the multiplier because we're adding it over and over again, right? So this should be the explicit rule. Let's check it with a couple of these. Let's check a sub 3. Let's check the third let's check the third term and make sure that we get the third term. So we do 42 plus 3 minus 1 times 8, which is 42 plus 2 times 8, which is 42 plus 16, and 42 plus 16 is 58, and the third term in my sequence was indeed 58, so that's good. Let's check one more. Let's check the fifth one. Let's check the fifth term, just to make sure that this works. If two of them work, I think we'll be okay. But if you only check one, the problem tends to be that if you only check one, then you can have a false positive result. That is, you might have a coincidental correct answer. Think of if I told you that multiplication and adding weren't the same thing, but you did 2 plus 2 and 2 times 2 on the calculator, you might be fooled into thinking that adding and multiplying were the same operation, because in that one case, you get the same answer in both. So let's check a second one, just to be sure. So we'll do 42 plus, and now it's going to be 5 minus 1 times 8, which is 42 plus 5 minus 1 is 4 times 8. So that's 42 plus 4 times 8, which is 32, which is 74. And our fifth term was indeed 74. So I feel a whole lot more confident now in my answer. All right. I'll give you a moment to look at that. All right, let's move on to the next problem. And now let's talk about the sixth term. What would be the sixth term of an arithmetic sequence? Well, actually, let me take that back. The sixth term is 3 over 2. And the 12th term is 5 over 2. And the question is, what is the common difference? Write the explicit rule. Okay? So we've got, let me sort of make a picture out of this. We've got the first term, the second term, the third term, the fourth term, the fifth term, the sixth term, but I know the sixth term. The sixth term is 3 over 2. The seventh term, the eighth term, the ninth term, the 10th term, the 11th term, and the 12th term. So now I actually want to focus on writing the explicit rule first. Okay? Oh, and I know the 12th term. Sorry, let me fill that in. And the 12th term is 5 over 2. So let's focus on writing the explicit rule first. And the way we're going to be able to do that is we have two of them. We can set up a system of equations. Okay? The way these always work, as we can see from here and before and stuff like that, is you have your a sub n equals your first term plus n minus 1 times your common difference, which let's put that as a D for difference. That is the thing you're adding over and over again. It's called the common difference because if you subtract two numbers next to each other, that's the number you get. Okay? So I have some information that can help me with this, right? I have the sixth term, and I have the 12th term. The 6th term is 3 over 2. The 12th term is 5 over 2. So the way I'm going to do this, I don't know if it's the way that Edgenuity shows you how to do it, and I don't think that it is, right? But this is a pretty solid technique in a lot of different situations. So I like tools that I can use over and over again. And systems of equations stuff is a tool that you can use over and over again. So I can do 3 over 2 equals, I don't know A1, that's one of the variables I'm trying to figure out, plus n minus 1, this right here, which I actually do know this time, is the n is 6, so 6 minus 1 is 5 times d. Okay? And then I know the 12th term, which is 5 over 2, equals A1, again, plus 12 minus 1 is 11 times d. So why don't we make everything in the top negative. I'm going to solve this by elimination. And that's going to get me, at the moment, it's going to get me my common difference, right? So if I do negative 3 halves plus 5 halves, that's 2 halves, 2 over 2, or 1. Negative a sub 1 plus a sub 1 will cancel those, so that'll just be 0. Those will be canceled. And then negative 5d plus 11d is just 6d. So all I'm going to do to solve this, so now I've got 1 equals 6d, and I'll divide by 6 on both sides, and that'll give me 1/6 equals d. So what is the common difference? The common difference is plus 1 over 6. So I'm adding 1/6 each time. Write the explicit rule. Well, that should be pretty easy now. The only thing that we don't have is A1, right? So I'm going to do some work to figure out what a sub 1 is, and all I'm going to do is take one of my original equations from here and plug in and solve. So I had 3 halves equals A1 plus 5d. Oh, but I know d now, times 1/6. So it'd be convenient if I have everything in terms of sixths. So I'm going to do 3 over 2 times 3 over 3. 3 over 3 is a clever version of 1 that gets me a common denominator of 6. So that'll be 9 over 6 equals A1 plus 5 times 1/6 is multiplied to the top only with the number that is not a fraction. So it's 5 times 1 and then over 6, which is 5 over 6. And then I will subtract the 5 over 6 on both sides. And 9/6 minus 5/6, you keep the common denominator and subtract the top. So 9 minus 5 is 4 over 6 equals a sub 1. And I can reduce that by 2. I can divide both of those things by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. So A1 is, let me make a note of that here, A1 equals 2 over 3. And then I have everything I need to write my explicit rule, and I can write that right down here, A sub n equals A1, which now I know is 2/3, plus the quantity n minus 1 times d, my common difference, which I now know as positive 1/6. And there is our explicit rule. There is our common difference. I'll give you a moment to look at that. And that concludes the problems for this section. Thank you so much.